And here we go. Wonderful. Thank you everybody for joining us tonight for another Sky Tonight presentation by the Fleet's resident astronomer. Yes, that's how fancy we are. We have our own resident astronomer at the Fleet Science Center. Her name is Dr. Lisa Will. Some of you hopefully know her already. I hope we have many friends of the Sky Tonight show with us today. If this is your first time, welcome. We're glad you're here. This is our monthly astronomy talk, which we would normally have at the Fleet Science Center in our beautiful Hycroft Dome Theater. Unfortunately, this is not possible right now, as you might know. But it's super wonderful that science and technology make it possible that we can still bring some astronomy to your life through the digital media. So here we are online, and tonight we're going to talk about Venus. A couple of housekeeping rules before we get started. We are not able to see or hear the audience, but you can still engage with us, which I hope you will do through the Q&A function. You're welcome to ask questions in between. I'll keep an eye on them, but normally we get to the questions at the end of the presentation for our Q&A session. But please, you don't want to forget the question. You just type it into that Q&A function. That's the little speech bubble at the bottom of your screen in the control panel. Just type it in there whenever the question pops into your mind, and we'll be sure to get to it. And I think that's all I wanted to say for now. So Lisa, why don't you go ahead and take it away?
All right, thank you. Hi, as Andrea said, I'm Dr. Lisa Will. I'm a professor of physics and astronomy at San Diego City College and the resident astronomer at the Fleet Science Center. And I'm excited to be back with you tonight to present the Sky Tonight program. The Sky Tonight is a program we do the first Wednesday night of every month, where we give you a tour of what's up in the sky tonight. And then we specialize to different topics every month. And like we said, tonight we're going to talk about Venus, which you may have noticed shining very brightly in the morning sky currently. So let's go ahead and attempt to share my screen. There we go.
Perfect, that works.
All right. So I wanted to start off though by talking about something that was very prominent in the news, and that was Comet Neowise. And you may have heard of this. This was a comet that was visible to the naked eye in mid to late July. And this is a picture that got a lot of play on the internet by Matthew Brown, taking a picture of taking a photo of Comet Neowise and noctilucent clouds over Stonehenge. I had some people contact me, and hopefully I could help you a bit when you asked about how can I go outside and look for it. It was really hard to find. And so I have some photos from a retired member of the Fleet family, Mary Anderson, who we let retire a few years ago, and she does absolutely wonderful astrophotography. And I wanted to show you basically what she saw, because I think it'll give you a little bit better context. If you had a hard time finding it, this is why. So what you can see here is Comet Neowise, that little fuzzy blob, and you can see it below the Big Dipper. Up there, the Big Dipper shining very brightly. So the Big Dipper, as we'll see when we take a tour of the sky, is actually really low in the northeastern part of the sky right now. So I think a lot of people were going outside looking for Comet Neowise and not finding it because they weren't looking low enough. So basically my suggestions to people was you had to look low enough that you felt like your neighbors were going to get upset that you were looking into their house, right? That was kind of how low it was on the horizon. And Mary took a couple of photos from here in San Diego. She was near Crystal Pier. So here it is from Pacific Beach. And you can see that tiny little fuzzy blob above the clouds and above the pier. Let's get some other looks. So here she helpfully drew in where the Big Dipper is and circled the comet. And you can see it where it is in perspective with Crystal Pier. So it was really low on the horizon. So I was lucky enough, I actually managed to find it a couple times. I saw it once with the naked eye. It was a tiny little fuzzy blob, and I'm like, I bet that's what I'm seeing, because it was really hard to see here in the city lights. I had better luck with binoculars, and yeah, I felt like neighbors were going to say, why are you looking in my second floor window, right? Because that's how low it was. So if you didn't see it when you went out there and looked, there's lots of beautiful photographs, even photographs taken from right here in San Diego by very people who are much better at doing astrophotography than I am. So that was Comet Neowise, a naked eye comet that was visible. Some people are still getting it with telescopes. It's not visible to the naked eye anymore, but hopefully you had a chance to see it. Speaking of something related to comets that will be happening this month, August is when the Perseid meteor shower happens. The Perseid meteor shower happens, well, meteor showers in general happen when, as the Earth orbits the sun, we cross through the orbit of a comet. And comets are little dirty snowballs, basically. They're made of mostly ice and some rocky properties. And as they go in their orbit around the sun, bits and pieces of them break off. And when the Earth crosses through that orbit of the comet, then there's all those little bits of debris that we pass through. And those little bits of debris hit our atmosphere and burn up in the sky, making meteors, those little bright streaks in the sky. We actually know what comet causes the Perseid meteor shower. That's Comet Swift-Tuttle. And because we know the comet, we know, and we hit this at the same point in the Earth's orbit, so at the same time of year, from the same angle. And so meteor showers are named after the constellation that it looks like they're coming from. So if you want to go outside and watch the Perseid meteor showers, they peak this year, the nights of August 11 and 12, then that's typically when they peak. But if you go outside tonight and you see a couple of meteors, that's probably part of the Perseid meteor shower, because they have a strong peak, but it kind of has a sort of a bell curve of probabilities of running through and getting some meteors from it before and after this peak. And you'll want to go outside after, say, 11 o'clock at night, so you can see Perseus as it is rising and the streak across the sky. And this is a pretty consistent meteor shower over the years, with anywhere from about 60 to 150 meteors per hour. So how does that compare to a regular night? If you and I were to go outside tonight and not have clouds interfere and we just looked up at the sky, we would see on average about 1 meteor per hour. That's just random. Meteor showers are when about a dozen or more hit per hour and happen at a regular occurrence. And so hopefully you'll have a chance to see some of the Perseid meteors. And a few years ago, Mary Anderson took this picture of a Perseid meteor out in the desert with a dinosaur for effect. Other things you may have been hearing about in the news, the Mars 2020 rover, which has been named Perseverance, launched, and that was on July 30th, and it's on its way to Mars, and it should get to Mars in February of 2021, so in the next winter. And its mission is to, like all Mars missions, they tend to look for water on Mars and signs of whether or not there could have been life on Mars previously. This one's also going to collect samples to send back to the Earth. And it's also going to look to see if it can, it's in its goals to understand Mars geology and perhaps even biology better. It will be seeing if it can process oxygen out of the CO2 that we have on Mars, so that if we ever were to go on to Mars ourselves, we wouldn't have to bring oxygen with us. And then another instrument that it has on this rover is actually a little helicopter. It's not going to do any science. It's sort of a proof of concept. Can we fly in the very thin atmosphere of Mars? And so it's going to basically, let's think of it like a little drone, and it's going to try, so it's just going to try to do a flight test to see if it can fly. It's going to attempt a couple of little flights on Mars. So like I said, the Perseverance rover, this is called the Mars 2020 mission as well, launched last week and is on its way to Mars, and it shall get there in February. All right, this image doesn't look special, but it's an interesting image. So let me tell you what you're looking at. The big blob in the middle that kind of looks like the eye of Sauron, that's a star. And what astronomers have done is they've taken a mask and they've subtracted out some of the light from that star so you can see the stuff around it. The two dots with the arrows pointed at them, those aren't stars, those are planets. And this is an actual image of two planets around a star other than our own, captured by the SPHERE instrument on the European Southern Observatories Very Large Telescope. That's the name of the telescope. It's called the Very Large Telescope, okay? So we'll call it the VLT. So it has an instrument on it that took these pictures. And what's really awesome about this image is that the star that has been blocked there is a star very similar to our own sun. And so this is the first time that we have seen that we've actually been able to take direct images of planets in orbit around a sun-like star. In order for us to see them in an image, because stars are really bright. So if this was our solar system and we were looking back at it, you wouldn't be able to see the Earth or anything because the Earth would be too close to its star. So these are two large gas giants, and they're way, way, way far away from their star. Think of them being out way past where Neptune would be in our solar system. Because in order for us to take an image of a planet around another star, it has to be big enough to still shine by its reflected starlight, but far enough away from its star so it's not getting lost in the starlight. And so this, like I said, this is exciting. This is the first time we've seen multiple planets in orbit around a sun-like star with the benefit of imagery. And this is a star that only has a catalog number. You would have never heard of the star. And it's in the constellation Musca, which is a southern constellation visible from the southern hemisphere. So that's a new one. And then this bit of news just showed up on Twitter as I was scrolling through today. And you might be wondering, what are you looking at here? Well, the picture on your left is actually a close-up image of Jupiter taken by NASA's Juno spacecraft. And so you get that beautiful swirling motion that always reminds me of like putting cream in coffee or tea. Jupiter is a gas giant and its atmosphere behaves like a fluid. So we see these beautiful fluid flows in it. Now you'll notice directly in the center of the image, there's a set of white clouds that seems to be brighter than the others. Well, what the image on the right is attempting to show is what we think is happening in that bright sort of uplifted white cloud region is lightning. We know that Jupiter does have some lightning storms on it, and we've been interested in figuring out what the mechanism is, because here on Earth, lightning goes from the clouds to the ground. That's not happening on Jupiter because Jupiter doesn't have ground, right? Jupiter has a core way down deep, but it doesn't have ground. So there had to be a mechanism for some shallow lightning. And what they think is happening here also would explain why we don't see as much ammonia in Jupiter's clouds like we do on some of the other gas giants. And so we think that we're basically getting some electrical discharge in an ammonia water solution. And so to show you, the image on the right now is sort of an artist representation of what they think is happening in those clouds themselves. And so really sort of an interesting idea here, but we don't, so here's weather on Jupiter. We're seeing lightning storms on Jupiter. It's just not the same mechanism as lightning here on the Earth. And so that's just some of the news that's been going on in astronomy, trying to catch you up for what's been going on the last month. And the paper on this subject actually comes out in tomorrow's issue of Nature, I believe. So you're seeing something's a press release right here. All right, so let's go take a tour of the night sky. So I have the sky here set for San Diego at 9 o'clock tonight. So to get you relative to where you are on the screen, south would be at the bottom of the screen, north would be to the top of the screen, east is to the left, west is to the right. And so the point directly over your head would be the point right in the middle of your screen right now. So let's take a tour starting with some popular constellations, and this is the constellation Aquila, the eagle, thought to represent a bird, actually an eagle from Greco-Roman mythology. This eagle occasionally would carry Zeus's thunderbolts. And the brightest star in this constellation is named Altair, which comes from an Arabic phrase that means the flying eagle. And Altair is one of the brighter stars in the summertime sky. It's about 17 light years away from our solar system. A light year is the distance that light travels in a year. So if you go outside to look for Altair tonight, and I'll show you a way that you can find it in a bit, you wouldn't be seeing Altair as it is, but rather as it was 17 years ago, because that light from it had 17 light years to travel to us. Another bright constellation up in the sky tonight is Cygnus, the swan. also sometimes referred to as the Northern Cross. The brightest star in Cygnus is Deneb, and you'll see it there located in what would be the tail of the flying swan. And it is one of the brighter stars in the summertime sky, and it's about over 3,000 light years away from our solar system. So if you were to go outside tonight and if the clouds cooperate, you would see Deneb and Cygnus and Altair and Aquila look very similar in brightness to you, but they're really, really, really different distances from us. One only being about 17 light years away and one being over 3,000 light years away. And that's just a reminder that you don't have depth perception on the sky. Stars can be bright and far away. They can be faint and really close by. And that's one of the reasons why distance is one of the most difficult things for astronomers to figure out. Next constellation I want to mention to you is Lyra, the harp of Orpheus from Greek mythology. Its brightest star, Vega, is the fifth brightest star seen in the Earth's evening sky. It's about 25 light years away from our solar system. And if you went outside to look for it tonight, it would be a very bright white dot in our sky. And all three of those stars, Deneb and Cygnus, Altair and Aquila, and Vega and Lyra, make up something that we refer to as the summer triangle. So this is how you would go outside to look for it tonight. If you go outside, 9 o'clock, maybe closer to 10 o'clock. If you're out there, it would be almost directly above you. You look up, you'll see three bright stars making a big triangle, not a little triangle, a big triangle on your sky. That's called the summer triangle. And that'll be these three stars for you. Now, these are bright stars, and you might have even heard of a couple of the constellations that they're in. I want to talk about a couple of fainter constellations you might not have heard of. Corona Borealis, the Northern Crown. The brightest star in it has two names. It's either called Gemma or Alphecca, both a reference to jewelry, because it's the people looked at this and saw this little curve on the sky and thought of it as being a crown. That bright star is located about 75 light years away from our solar system, and it's part of something called a binary star system, which means there's two stars in it. And that's actually true for a lot of the stars you see on the sky. You might call them by one name. You might see only one star, but there are multiple stars there if you take a look at it through a good enough telescope. Another faint constellation on the sky is Delphinus, the dolphin. This one has no truly bright stars. Like if you and I went outside to go look for it tonight, I would just say, oh, let's go look for the summer triangle and look a little bit to the east. That's how we'd find it. We wouldn't be able to look directly for any of the stars. And I've noticed when I've talked about this constellation before, a lot of people think like, oh, a dolphin, that sounds like it must be a modern constellation, but it isn't. It's actually one of those constellations that was first cataloged by Ptolemy back in the 2nd century. So this is thought to be one of the dolphins that helped or worked for or was loyal to the sea god Poseidon, however you want to talk about their relationship in that case. So this is actually one of those ancient constellations, a tiny little dolphin up in the sky. Now, a constellation whose name you've probably heard of before is Hercules, a mythological hero from Greco-Roman mythology. It is the 5th largest constellation of the 88 modern constellations that astronomers use today. And by modern constellations, I mean that in the early 1900s, there's been so many catalogs of constellations from all over the world. Professional astronomers and what we call the International Astronomical Union said, okay, let's actually settle on the constellations we're all going to agree upon to use as astronomers. So we call those modern constellations, although some of them derive from ancient catalogs of stars. Now, the brightest star in Hercules is named Kornephoros, which comes from a Greek phrase that means club bearer, because Hercules is usually depicted as holding a club in his hand as he goes on his adventures. And one of the creatures that Hercules encountered on his adventures was a dragon named Ladon. And we see that dragon in the sky here as Draco the dragon up in the sky. And it is a long constellation that kind of winds around the northern part of the sky. And its most famous star, Thuban, many, many years ago, couple thousand years ago would have actually been closest to what we would call the North Star. Because believe it or not, the North Star is not perfectly fixed. The Earth rotates on its axis once every 24 hours. It revolves around the sun once a year, and it wobbles like a top on its axis about once every 26,000 years. And so because of that, over periods of thousands of years, the direction of the North Pole, or basically the direction our North Pole points, is at a different direction in the sky. So if you and I were to take a time machine and go back in time 3,000 years, the North Star wouldn't be Polaris, it would be Thuban. Now, speaking of the North Star, how can we go out and find it? It's actually not as easy to find at this time of year because one of the things we usually use to find it is the Big Dipper, which is part of a larger constellation called Ursa Major, which is huge. It is the third largest constellation that we use today. And we typically take the two pointer stars at the end of the cup of the Big Dipper and use those to find the North Star. But for those of you who went out comet hunting last month and you saw how low the Big Dipper is on the sky, you know that it's kind of hard to use those stars right now to find them. But if you can find the Big Dipper, you can still use it to find the North Star, which is in the constellation Ursa Minor, or the Little Bear. And so this is also called the Little Dipper. You can see the similarities there. And so when you see the bright star at the end of the handle, that's Polaris, the North Star. And you can find it over a period of a couple of hours because the entire star will appear to be rotating around it. Because as the stars rise in the east and set in the west, just like the sun does due to the Earth's rotation, our northern axis points towards that North Star, points towards Polaris. And so Polaris appears to remain fixed on the sky. And that's Polaris's importance, is that we can use it to guide us because it does stay relatively fixed over periods of hundreds of years. In the northern hemisphere of the Earth, if you can find Polaris, it can guide you north and it can tell you your latitude. So here in San Diego, we're at about 32.5 degrees northern latitude, and we can go convince yourself of that because if you went to find Polaris tonight, it would be about 32.5 degrees above the northern horizon. So you can actually use it to find latitude here in the northern hemisphere. That's why it's a useful star. Some people think that Polaris became famous and useful because it was the brightest star in the sky, and it's not the brightest star in the sky. It's a decently bright star, but it's not the brightest star in the sky. And it's over 400 light years away, so we wouldn't necessarily expect it to be the brightest star in the sky either. In fact, it's pretty impressively bright for as far away as it is. So remember, because of the way light years work, if you go outside tonight and you take a look for the North Star on the sky, you're not seeing it as it is, but rather as it was over 400 years ago. Another constellation up in the sky tonight is Bootes, who is a herdsman. Its brightest star is named Arcturus. And when I take a look at it, a lot of people look at this and see a kite in the sky. I see an ice cream cone personally, and that bright star down at the base of the ice cream cone is Arcturus. And it comes from a name that means guardian of the bear because it's up there next to Ursa Minor and Ursa Major in the sky. And then the next constellation I want to talk to you about tonight is Virgo, the Maiden. It is the second largest constellation that astronomers use today, and its brightest star, Spica, is the 15th brightest star in the nighttime sky, located around 260 light years from our solar system. And Spica comes from a phrase that refers to an ear of wheat because Virgo the Maiden is also a constellation that is associated with being up in the springtime sky, and it's associated with fertility. Now, you may have heard of Virgo because it is a sign of the zodiac. So let me show you why it's a sign of the zodiac. So what is this green line that I put across the sky? Well, you'll notice it has months of the year on it. And so I have this set for 9 o'clock tonight. And so you can see that August is below the horizon because the sun would have set a couple of hours before. And why the sun? Because the ecliptic shows you the path of the sun on the sky. And so this is where the sun is located on any given day of the year. And so the constellations, excuse me, the constellations that the sun traveled through gained social importance. And those were the constellations that showed changes, because not only does the sun travel through them, but the moon and the planets tend to hang out there as well. So the signs of the zodiac are along the path of the ecliptic. And there are a couple of planets up in the night sky tonight, Jupiter and Saturn over there. And we'll take a closer look at them in a little bit, but they're actually up in the constellation Sagittarius tonight. So, and they are shining brightly. Jupiter is the brightest object in the sky right now if you go outside at 9 o'clock tonight. So now that we've defined what the ecliptic is, let's talk about some of the constellations along it. So we talked about Virgo. The next sign of the zodiac to the east, going west to east, is Libra, the scales or balance. It's the only zodiac sign that does not represent a living creature. And its brightest star is very hard to see from a city like San Diego. Libra overall is a faint constellation. Its brightest star is named Zubin el-Ganubi, and its name comes from an Arabic term that refers to a southern claw. The scales of justice don't have claws. What has claws is the next sign of the zodiac over, which is Scorpius, the scorpion. My personal favorite sign of the zodiac, simply because if you actually go outside and you look for it, it looks like a scorpion up on the sky. Now, I want you to notice that if you go outside and you want to look for Scorpius, you're not going to look way up in the sky. You're going to look down towards the southern horizon. And so if you want to look for it tonight, go for it, because there is a really bright red star in it named Antares. It's an example of what we call a red supergiant star, and it's huge. If we were to put it in our solar system where the sun is, Mercury, Venus, Earth, and Mars would be inside of it. And so, so go outside and take a look for a bright red beacon in the south, and that will be Antares in the constellation Scorpius. The next sign of the zodiac over to the east is, oops, wrong direction. It's Ophiuchus. Which is the 13th sign of the zodiac, which terrifies my students sometimes. They're like, Dr. Will, where did this come from? And I'm like, the sun goes through it, right? So the signs of the zodiac are those that fall along the ecliptic path of the sun. And so the sun actually goes through Ophiuchus in the first week of December. Now, Ophiuchus is supposed to be the serpent bearer, which makes a little bit more sense if we put the constellation Serpens up around him. So we have the head and the tail of Serpens on either side of Ophiuchus. So he's usually depicted as holding a snake up in the sky. The next sign of the zodiac over to the east is Sagittarius, which is meant to represent a centaur, or a half horse, half human, from Greek mythology. But what most people see when they go look for it is actually a teapot. So concentrate on the bright stars towards the middle, and you will see the teapot asterism. And you'll notice that Sagittarius is along that band of light going through the center of the screen. That band of light is called the Milky Way. And it is our galaxy as seen from inside of it. So we now know that our solar system is not located in the center of our galaxy. It's not located in the edge of the galaxy, but we're about halfway out from the center. And if I wanted to show you where the center was, I would say, go look where Sagittarius is. Sagittarius points towards the center of our galaxy. You might also notice that if you take a look at the Milky Way going across the sky, it's its widest and its brightest near where Sagittarius is, which makes sense. We got a couple 100 billion stars in our galaxy, and if we're looking towards the center of it, we'd be seeing more of them concentrated there. And so that's another one of the ways we know that the center of our galaxy is over in that direction. And the center of our galaxy, located about 27,000 light years from our solar system, that's also where the supermassive black hole is at the center of our galaxy. So if anyone ever says, like, point to a black hole in the sky, point towards the constellation Sagittarius. You'd at least be aimed in the right direction for the supermassive black hole at the center of our galaxy. And then those two bright dots to the east of the blue line drawing, those are Jupiter and Saturn. So if you wanted to go look for Jupiter and Saturn tonight, Sagittarius is where you'll be looking, right there. And so these are two images of Jupiter and Saturn taken recently. This was the astronomy picture of the day on July 29th. These images were taken by Jean-Luc Dauvergne from a balcony in Paris, actually. And so this is what these two objects would look like if you were to go take a telescope and look at them yourself right now. Jupiter is the largest planet in the solar system, over 11 times the radius of the Earth and over 300 times the mass of the Earth. Saturn is the second largest planet of in the solar system, about 95 times the mass of the Earth and almost 10 times the radius of the Earth. And the rings are really what sets Saturn apart. Jupiter has rings too. You notice how you don't see them? Yeah, Jupiter's rings can only be seen if you're basically have a spacecraft nearby to Jupiter. But all the gas giants, Jupiter, Saturn, Uranus, and Neptune, do have rings. Saturn's, though, are the brightest and most prominent right now, which makes Saturn a really good target for a telescope or even a pair of binoculars. If you have a pair of binoculars and wanted to go outside and look at these objects tonight, you would likely be able to pick up the 4 largest moons of Jupiter, maybe even some of the stripes on Jupiter, and you'd be able to tell that Saturn's a little squished. The rings make it look kind of like a disk on the sky. And those were the 2 planets that are visible with the naked eye up in the sky tonight. And then the next sign of the zodiac over to the east is Capricornus, the sea goat. It's a really faint constellation, very difficult to see from a metropolitan area like San Diego. So basically, if you wanted to find Capricornus tonight, go look for Jupiter and Saturn, and then look to the east in line on sort of a west-east line. So go to the east of it, and you'd be looking towards the direction of Capricornus. If you're in a sky, if you're out near a dark sky, you would be able to see it. But harder if you're in downtown San Diego, for example. So these are some of the bright stars and planets up in the sky tonight. You might be hearing one of my dogs having a conversation in the background. My apologies. There's no controlling her. But the constellation, or excuse me, the star I wanted to talk, I can hear my husband shushing her. It's funny. Sorry. I gotta love working from home. So one bright object you may have seen if you're up, say, walking your dogs early in the morning is a very bright star rising in the east, but it's not a star at all. It's actually the planet Venus. So let me switch our perspective to about 4:30 tomorrow morning.
Sorry, Lisa, can I ask a quick question before we go to
course.
Venus? Because there's one question about Saturn rings. Is it true that Saturn's rings are only about 10 meters thick?
They're really thin. They're really thin. So the way I usually keep it in my head is the width of the rings, and these are only like to relative scale, it's not perfect, but think of the width of the rings as being about the same distance as from the Earth to the moon. So that's on that size. And then, yeah, 10 meters isn't a bad idea. I think of it in terms of houses, right? And so it's a couple houses. They can be very thin in some parts, definitely. So they're really, really, really skinny. So that when you take a look at Saturn in a telescope, so Saturn takes about 30 years to revolve around the sun once. So sometimes we see its rings really prominently, but because of its tilt, sometimes they disappear from our view, and that's because they're so thin. So yeah, they are really, really thin.
Thank you so much for that. Appreciate
Thank
it.
you. So what I have here is the moon will be rising later this evening. The moon will be rising around 11 o'clock or so tonight, and it's in the waning gibbous phase. And so if you were to be outside at 4:30 this morning, the moon will be over in the western part of the sky not long from setting, and then there'll be this bright dot, Venus, up near the ecliptic over there, shining as sort of a bright beacon over in the sky. So I wanted to talk to you a little bit about Venus, because Venus is a really interesting world. So here's an image from last spring. Some of you may have noticed, and Venus was very bright in the evening sky last spring. Well, the way it was behaving in the evening last spring is kind of the way it's behaving in the morning sky right now. And so this is an image taken by Fred Pasternak of Venus against the Pleiades, or the Seven Sisters, a star cluster up in the constellation Taurus. So what makes Venus interesting? This is what Venus would look like through a small backyard telescope. What we can notice about Venus from the Earth is that it's fuzzy, which means it has an atmosphere. Venus is also about the same radius as the Earth, just a little bit smaller, about the same mass as the Earth, and it's about 70% the distance between the Earth and the Sun. So we're about the same size and about the same part of the solar system, made out of the same stuff. And so for a long time, it was thought that Venus was Earth's sister planet. In fact, due to its mass and radius, if you were standing on the surface of Venus, you would feel about 90% of your weight because the gravity of Venus is about 90% of the Earth's gravity. So we look at this and we see, oh, it's Earth's sister planet, closer to the sun. Maybe it's a bit more tropical, right? And maybe it's a little bit warmer. No, Venus is weird. So this is a animation made by James O'Donoghue. And what you'll notice here is the rotation and the tilts of the planets in the solar system, and also Pluto and Ceres, which is the largest asteroid out in the asteroid belt. And you might notice that Venus, all these planets, for the most part, look like they're zipping around with a couple of exceptions. Mercury is turning very slowly. It spins once every about 60 days. And Venus is also rotating really slowly. It takes about 243 days to rotate once. And you can either think of it as rotating backwards or upside down. We don't think Venus formed this way because, as you might notice, the majority of the objects in the solar system are all orbiting or rotating in the same direction, and they all orbit in the same direction around the sun. So we think that there is sort of a mass counterclockwise motion around the sun. And the fact that Venus is either upside down or rotating clockwise, depending on how you want to think about it, means that something likely happened to Venus. We think that this was probably the result of a catastrophic collision, not that it was formed this way. So that's one indication that Venus is not Earth's sister planet. And the other one is its atmosphere. Don't get distracted by that little black spot down at the bottom of this image. That's an image artifact. It's not actually a real. This is an image taken by the Galileo spacecraft, which is a spacecraft that actually went out to Jupiter, but did a bunch of flybys of the inner solar system before it got out to Jupiter. And so this is real true color, basically, images of Venus from right above it. And you can't see through its atmosphere. It's got a really thick atmosphere. This is why Venus is so bright in our sky. It has a highly reflective atmosphere. So it's close to the sun, it's close to the Earth, and it reflects a lot of light. And that's why you sometimes hear it referred to as the evening star or the morning star, although it is not a star. These are some other images of Venus. They're both by the Mariner 10 spacecraft. So the one on the left is visible light, and this was taken in the 70s, and the other one that I showed you was taken in the 90s. So you can tell that Venus looks the same over long periods of time. The one on the right is an image of Venus in the ultraviolet. And so what you're seeing here is solar ultraviolet radiation reflecting off of its clouds. And I love that image because you see that the atmosphere is circulating quickly. That you see sort of like jet streams. There's a motion to the atmosphere, that the atmosphere is circulating very efficiently there. And that does turn out to be important. That really thick atmosphere is why Venus is not just not a sister planet to us at all. It is like one of the nastiest places in the solar system. This is a radar map of one hemisphere of Venus taken by NASA's Magellan spacecraft. And so you might be wondering, why is it color-coded red and orange? Well, by the time the sunlight gets, this is actually kind of, I don't want to say it's true color. It's not quite true color, but it is trying to correct for how the sunlight filters through that really thick atmosphere and gets to the surface. And I also think it gives you an idea of how just unpleasant that Venus actually is. So we'll get back to its atmosphere in a few moments, but you might be wondering, so what are some of these surface features that we're seeing? Well, one of the great things about looking at Venus with radar, and this is actually a radar image from NASA's Magellan spacecraft, which was active in the 90s and is was a really successful mission that hardly anybody remembers because it only sent back radar images. And so you might be like, Dr. Will, where are the pretty pictures of the surface, right? I'm like, there aren't any because that atmosphere is so thick, we can't see through it in visible light. So we look at it to see down to the surface from above the clouds, we look at it with radio waves. And now the great thing about doing radar maps is we can build up topographies. So I can now imagine standing on the surface of Venus and looking at this volcano from the side, which is what we're basically doing here. Venus does have volcanoes on its surface, mostly shield volcanoes, and there's some really interesting indications that Venus is still volcanically active. But because we cannot see through the cloud cover, it's hard for me to say, like, look, here's a volcano erupting right now. We can't really do that, but there are some interesting indications that it's still volcanically active, which you would expect because, once again, Venus and the Earth are made out of very similar materials, about the same size. You would expect their insides to still have perhaps the same level of internal activity that could drive volcanism. So have we ever seen the surface of Venus in visible life? And the answer is briefly. So these are some images from the former Soviet Union's Venera 13 spacecraft. And you'll notice the top one, it says color as seen from the surface and with atmospheric effects. And you might be wondering, how do you know how to correct them? Do you see that sort of red and white strips over to the right, kind of moving, like it looks like a stick? It's supposed to be a ruler, and so that you can get sort of size and color correction to the images. Every time we send a rover, there's usually something that helps us estimate size and enables us to do color correction. So that's how we could actually get the color correction with the atmospheric effects. And you'll notice the camera's kind of pointed down a little, so we didn't like discover machinery on Venus. We're just seeing the spacecraft itself, the lander itself there. And I don't know about you, but this looks like really dry dirt, but the flatness of some of the rocks reminds me of desert hardpan. And so that perhaps gives an interesting clue as to what happened to Venus, because we don't think that Venus's atmosphere today is what it formed with. So let's talk about the atmosphere a bit more. These are two images from the European Space Agency's Venus Express spacecraft. On the left-hand side, you have visible light, and we're looking over the one of the poles here. And on the right-hand side, you're seeing infrared. And you're once again seeing that swirling connectivity, the jet streams in Venus's atmosphere, and it's hot. I think when you take a look at its atmosphere in the infrared, you get a feeling that there is heat in that atmosphere, and there is. This is a more recent set of images from the Japanese Space Agency's Akatsuki spacecraft. And you can once again get that feeling of, these are infrared, and you're getting the feeling of the heat and the turbulence in Venus's atmosphere. So what's up with Venus's atmosphere? Venus's atmosphere, those really reflective clouds are made out of sulfuric acid, which is, well, I told you it was unpleasant, right? So how do you get sulfuric acid? Well, Venus's atmosphere is mostly carbon dioxide, over 96% carbon dioxide, about 3.5% nitrogen, with water vapor and some argon and some sulfur dioxide in the atmosphere. Now, if I were to give you sulfur dioxide and water in a chemistry lab, you could make sulfuric acid out of it. So these sulfuric acid cloud droplets, they are actually form natural chemical reaction up in the atmosphere. You might also notice that on the right-hand side, we have atmospheric pressure labeled, and 1 atmosphere, which is what you and I feel here on the surface of the Earth, is all the way up in those nasty cloud layers. Whereas if we were standing on the surface of Venus, we would feel an atmospheric pressure of 90 Earth atmospheres currently. What does that mean? It would be like you trying to take a deep breath while being a kilometer underneath the surface of our ocean. It's a very heavy atmosphere weighing down on us. So why is that? Why is Venus's atmosphere so different than ours? This is an example of the runaway greenhouse effect. So what we here have is a comparison of the Earth's atmosphere and Venus's atmosphere with the way the greenhouse effect works. So light comes from the sun. A lot of it reflects off the Earth. It hits clouds, it hits the surface, it hits the oceans. That's how we see the Earth shining, that beautiful blue marble. But what makes it to the ground can heat up the surface, which re-emits infrared radiation. And that infrared radiation gets absorbed and re-emitted in the atmosphere, making sort of a nice blanket around the Earth. Well, on Venus, Venus is really, really reflective. So it actually reflects about 70% of the light that hits it. So only 30% of the light from the sun gets in. But what gets in, it keeps. And so, because its atmosphere is mostly carbon dioxide, which is a greenhouse gas, it keeps over 90% of the infrared that gets through. And so, Venus is actually an example of why we worry about climate change and global warming here on the Earth. Because once the greenhouse effect gets out of balance, and by out of balance, what I would mean here on Earth, uh, the greenhouse effect is sort of nice and mellow for the most part. If we didn't have the greenhouse effect working in our atmosphere, the Earth would be much colder than it is. But right now the greenhouse effect is working such that the water cycle is in balance, because water vapor is another very important greenhouse gas. Venus was always a little bit too close to the sun, too close for the water cycle to ever be in balance. So the water that would have been on the surface of Venus originally evaporated up into its clouds or into its atmosphere, and the carbon dioxide outgassed up into the atmosphere as well. And so whereas the Earth has sort of a nice blanket of greenhouse gases, Venus has a very, very heavy quilt. And we do worry about the Earth's greenhouse effect getting out of balance, because then we'd be Venus. That's the big concern there. And we anticipate that our atmosphere would be mostly carbon dioxide and have an atmospheric pressure of about 70 of our current atmospheres. Now, what does the greenhouse effect do to Venus? Well, that means that although it's rotating very slowly, the nighttime temperature and the daytime temperature are about the same. The temperature at the poles is about the same as the temperature at the equator. So it's like almost the same temperature. It's pretty much the same temperature everywhere on the planet. And that temperature is about 855 degrees Fahrenheit. It is actually hotter than Mercury, even though it's about twice as far away from the sun, due to the greenhouse effect working in its atmosphere. So that's our goal, is to not be Venus when it comes to the greenhouse effect. The Earth won't get just a little bit warmer. It will be unlivable for life as we currently enjoy it here on the Earth. And then what else does Venus have going on? Well, Venus doesn't have any moons. It's one of the few planets in the solar system that doesn't have any moons. And because of its slow rotation, it doesn't have a magnetic field. We think planets form their magnetic fields by rapidly rotating liquid metallic layers inside. And so even if Venus did have a liquid metallic layer, it's not rotating fast enough for it to generate a magnetic field. And so without the magnetic field, the solar wind from the sun actually directly hits Venus's atmosphere. So Venus's atmosphere is getting sort of picked off a little bit. Now this makes it look very dramatic. This makes it look like if we went outside tomorrow, Venus would have no atmosphere. It's not that dramatic. This is also happening to a certain extent with Mars. Mars has a very weak magnetic field, and this is one of the ways that Mars is losing a little bit of atmosphere as well. So one last image for you. This image was an astronomy picture of the day back in April, and it was taken by Scott Aspinall. And he's showing in this image, you have the Pleiades up at the top in Taurus. You have the moon, a crescent moon over to the left, and a Venus shining brightly over to the right, just to give you an idea of how bright these objects can be. So that was just a quick tour of Venus up in the sky. And now I'll answer your questions.
Perfect. Lisa, would you mind taking your screen down so we can see you?
Oh, no. Okay.
Yes, we want to see you.
Oh, okay. There we go.
Okay, before I read the questions to Lisa, I'm going to throw up a little poll because we like to learn and hear from you. So I'm going to throw that up there. So while you listen to Lisa answer questions, if you wouldn't mind just casually filling out the poll, that would be fantastic. Thank you so much. So first question that we have, is Venus smaller than Mars?
No, Venus is actually not smaller than Mars. Venus is about the same size as the Earth, and Mars is about, if we talk about in terms of radius, Mars is about half the radius of the Earth. So Venus and Earth are significantly larger than Mars, actually.
Okay, thank you.
We tend to think of them all being about the same size, but Mars is smaller.
And then the next question we have is, where is the VLT, the Very Large Telescope, located?
I believe, if I recall correctly, it's in Chile. And so it's run by a group called the European Southern Observatory, which is a consortium of telescopes that operate in the southern hemisphere of the Earth.
And the next one is, how thick is Earth atmosphere? And if we, I don't know if I read that right, if we waste asmus,
I
and
think it says if we waste the atmosphere and pollute it, will we not get any more?
I think so too, yes.
All right.
Thank you, Lisa.
No, no problem. We will not get any more atmosphere. Uh, in terms of the thickness of our atmosphere, I always like to talk to my students about it. I always introduce it as Earth's fragile atmosphere. It's very thin. Remember, we can see through it from we can look out and see stars, right? We can go outside and take a look at the stars up in the sky, which means we have a translucent atmosphere. And it's actually, I always think to scale, imagine having a yardstick or a meter stick and drawing a circle with it up on a chalkboard with a piece of chalk. The depth of the Earth's atmosphere would be about the width of that, the chalk line there. So it's very, very thin. And therefore there's not so much of it that we can't make changes to it. And we don't really have ways of making more easily in terms of nature, ways that things can get into the atmosphere. We can outgas stuff from volcanoes and geysers and stuff like that. As the permafrost is melting in the Arctic, we are getting contributions to the atmosphere of the stuff that had been previously locked up in the permafrost. And so one of the things we're worried about in that case is that there's methane locked up in that, which is a very effective greenhouse gas. And when we talk about how could we give, say, Mars more of an atmosphere, one of the ways we think of it is like, well, let's hit it with a comet and let the comet, like, water vapor evaporate up into the atmosphere. That would work, but we're really not, we don't want that to happen to us, right? So yeah, replacing an atmosphere is not easy to do.
Good, so we should all make sure we're not wasting ours.
That's right.
And then the Mars Perseverance that just
Mhm.
went up, are they bringing back the samples or just sending data?
The way I have read about it is they say it's doing sample collection. So off the top of my head, when I see sample collection, that usually sounds like they're bringing something back. But these are all mini chemistry labs, and so when they do gather samples, they are always sending stuff back. But let me actually say, yeah, they are. I'm just skimming through my notes. Yeah, it is a sample return mission, so it should be ejecting stuff back to the Earth.
All right, cool. That's exciting. And then could something be big enough to impact Venus to change its orbit, but not big enough to destroy it outright?
Yeah, that's a fantastic question because I don't know if you noticed back on the slide where I was showing the orbits of, or the rotations of the planets, that Uranus was on its side too. And so we also think that was probably a catastrophic collision. So, and then we also think that our moon might have been formed by the impact of a Mars-sized object onto the Earth. So once again, it's all about speed, size, and angle of attack. And what we think probably happened with Venus isn't something so much that hit it and made it roll over, but that it was turning and it got spun back. And so it was probably, it would have had to have been a glancing blow, if that makes sense that way. But yeah, we can get this to work in computer simulations.
So we can knock it off course without destroying it.
Yeah, we can change its orbital characteristics without destroying it in simulations. We can't throw something at it, unfortunately.
No, why would we? Does Venus have tectonic activity, and do we know anything about its primary element composition?
Good question. So when we take a look at Venus, because the Venera landers did land, we do have some ideas about what the surface is made out of. And the way I like to think of it is that Venus and the Earth have pretty much the same densities. They have similar iron contents in their rocks. very, very, like in terms of the dirt ball of the planet itself, very, very similar compositions. And that's to be expected because if you take a look at the size scale of our solar system, Venus and the Earth are practically on top of each other, which means they formed out of the same stuff and pretty much at the same time too, because we think all the planets formed with the sun as it was forming out of the same stuff. And it's just that the closer to the sun, less fragile materials could survive, and so that's why we see the icy stuff and the gassy stuff further out in the solar system. At least that's some of our current ideas. Some of our observations of exoplanets mean that we still have a lot to figure out, to be honest. But yeah,
which is a good thing.
yes.
Still more to be explored and discovered.
Exactly.
From what is known, is Venus considered older, younger, or twin for planet age in comparison to Earth?
Great question. So we do think all the planets formed at about the same time. Some of them formed faster than others, though we actually think the Jovian planets, so think of all the planets starting to form at the same time. We think the Jovian planets probably would have finished forming quicker because as they built up more material, their gravity got bigger, and which means that they could lure more material towards them. So they were bigger and could get bigger. Because they were bigger, they got bigger faster, if that makes sense. It was kind of a snowball effect there. But Venus and the Earth probably started forming at about the same time, and they probably finished forming at about the same time.
Interesting. Thank you. And then, is it true that one day is longer than 1 year on Venus?
Yeah, they're about the same size. They're about the same length. Yep.
Cool.
Yep. Which is a really weird idea, but yeah.
Yeah, it is.
Although this year it kind of feels like every day is well, yeah.
Yeah, 2020 is
Yes. Time
not good
is
measure.
moving differently this year.
Yes, it is. And I think so. What time do the Perseus show up in the sky?
So when we name meteor showers, we name them after the constellation that they look like they're coming from. And you might have noticed the constellation Perseus wasn't one of those ones that are up at 9 o'clock tonight when I aimed the showtime for. So to go outside to look for the Perseids, you're better off going outside after, say, midnight, when Perseus gets a little bit higher in the sky, and then you should see the meteors arcing across the sky. So your goal, if you want to go observing meteor showers, you don't need special equipment. You don't need telescopes, binoculars, or anything. What you need is a big, clear expanse of the sky to see, to look at.
So I'm hoping for clear skies. I haven't even gone outside tonight yet. I don't know where we're going to be.
I live near the coast, so
yeah.
marine layer is a problem.
I'm in La Mesa. I should be good, but I'll check it out tonight. Are there Venusian caves under the surface where it might be cooler?
Ooh, that's an interesting question. I like it. Because we have difficulty observing Venus's surface with imagery, I don't think we have, I can't recall any definitive, hey, there's caves on Venus, although we have pictures of Martian caves. So I'm not going to count this out. We do see holes in some of the craters on Mars, and you can tell that there's like a cavern underneath. So I would expect that there are caves on Venus where it would be a little bit cooler, but the deeper you go into a world, the hotter it actually gets. So if we walk into a cave here on Earth, it typically gets cooler at first just because it's shaded from sunlight. But as you go deeper and deeper into the cave, it tends to get hotter. And as we go deeper and deeper to the planet, it would get hotter. So I can't imagine that we would necessarily find a pleasant climate necessarily in caves on Venus, especially when you figure out all the other difficulties that we have here in deep caves on the Earth in terms of gases and stuff to deal with. That would just be my instinct on that, though.
Are there other images from the surface of Venus? And what other mission to Venus have there been or are planned so that we can learn more about what the surface looks like and maybe caves?
Great question. So there are a few other images of the surface of Venus from some of the Venera probes that the former Soviet Union sent. The NASA has not had any landers, and part of it's because landing on Venus is just not easy. That whole big atmospheric pressure and high temperature, basically it's a pressure cooker. So designing a lander, like sending a lander isn't easy to Mars, but the climate for the lander is okay to deal with. The climate for a lander on Venus would be incredibly difficult to deal with because basically these images from the Venera probes happened before they kind of like got crushed by the atmospheric pressure. I mean, it's not an easy environment to survive in. I know that there have been missions pitched to NASA for funding to go back to Venus. There's been several missions to Venus just taking images from above the surface, though. Those Venera spacecraft images are really the only ones there. And I can't recall a plan for a lander anytime coming up anytime soon.
Yeah,
Sorry.
they all get crushed. That's a good engineering problem to have to tackle first.
Well, the thing is, the materials that would be sturdier would be heavier, which makes it harder to get. It's just, yeah, it's an interesting engineering problem.
Yeah. Why do probes, oh, we just talked about that. It's
That's
why do probes
very
not
good.
last long on Venus?
That's a very good question, Alistair. So thanks for asking it. It really is just not a very nice environment. It's really hot and really high pressure.
Yeah. And Alistair is 6. That's awesome.
That's
Hey,
awesome. Thank you.
we love you being here. That's fantastic. What do we know about the formation of the planet core of Venus versus other planets in our solar system?
So that's an interesting question. We actually think if we were to cut open if I could just take Venus and cut it in half and then cut the Earth in half and compare them, they would probably look very similar inside with similar material composition as well. Because what the Earth and Venus and Mercury and Mars are all made out of are very simple sets of silicates and so on, like the materials that are common here on Earth. We also see them common on the moon, common in other parts of the terrestrial worlds. The gravities of the different planets affected the size of their cores and the size of their layers in terms of proportions. So if I were to cut open the moon would look different because it's so much smaller that it didn't really that its structure, the gravity didn't force a dense core out of it, and it didn't. And also the moon, because it was likely made out of the surface materials of the Earth, doesn't have like the heavier iron core sort of thing. So there's a couple of different mechanisms that affect how planet cores are, but the cores would have formed first. We think all planets started off with a single dust grain that stuck to another dust grain and then built up through collisions and then started drawing material towards them by gravity. Yeah.
Thank you. Do you know what the first time was that somebody spotted the Big Dipper? And how many times?
No, and that's actually to me one of the really interesting things about astronomy is that astronomy can be done without any instruments whatsoever. We learn a lot more with telescopes and cameras and stuff like that, but we developed our sense of time with the calendar, just with the naked eye. There's so many things that we've done over the course of human history just by looking up at the sky. So I can't tell you when the first time it was that somebody looked at the Big Dipper, but several cultures in the northern hemisphere of the Earth looked up at that same collection of stars and actually referred to it as looking like a bear, which I kind of find interesting because that's not true for every constellation. But people saw that set in the sky and saw a bear. So that is the other interest to me, really interesting thing about astronomy. It is a shared experience. The sky can be seen by everyone around the world.
Yeah, it can bring people together, which is great.
Yes, and astronomers have catalogs that date back, oh gosh, over 2,000 years, basically 3,000 years at this point, existing documents.
Wow.
So it's a long-lived science at this point.
Yes. And then when was Venus formed?
So we think it would have formed when our solar system did, and we estimate the age of our solar system to be about 4.5 billion years at this point.
Okay, that is old. Next question. If the year and day are the same on Venus, does that mean it's tidally locked?
So that's a great question because we talk about it. So like the moon is tidally locked to the Earth, which is why it shows the same side to us all the time. The reason why Venus does what it's doing isn't because of tidal locking, though, right? So in terms of chicken versus egg, what came first, the gravitational interaction that forced them into this, or is it just circumstance? On Venus, it's circumstance at this
Hmm,
point. So it's not an exact tidal locking. It's not because of the sun's effect on it.
got it. And then if time allows, can you give an example to help us better understand how the moon rotation was affected? For example, an asteroid explosion in the Yucatan Peninsula potency could have been something that could have affected the moon?
So, okay, so you're talking about if something happened here on the Earth,
Yes, would it
so would it
affect the moon?
affect the moon? So we don't think that the large impact over the Yucatan affected the moon. That was an object. So the reference there, I think, is referring to the Chicxulub crater, which we think is the impact that may have helped the dinosaurs along on their path to extinction. We think that was made by an asteroid that was over a kilometer in size. So it was a big impact, but stuff like that could hit the moon and not affect the moon other than leaving a crater. So the way we, the Earth, are affecting the moon's orbit and its rotation is the moon is tidally locked, but it's not perfect. It wobbles a little due to something, it's called libration, and it's because it's spinning and we're spinning and it wants to keep one side always facing the earth, but it really doesn't. It's like 52% of it faces the earth over time, not just 50. So we get something called tidal friction. So the moon is actually getting further away from the earth and the earth's rotation is slowing to accommodate it.
Oh,
So we are affecting each other.
yeah. So will the moon just continue to keep going and eventually we'll have to say bye bye, moon?
It will not say bye bye moon. It is a conservation of angular momentum, or what I like to call the ice skater problem. The ice skater gets to their slowest rotation speed when their arm is furthest away from them and when your hand becomes locked above your shoulder. And so there will be one point where the moon will always remain above the same point on the earth.
Oh,
And at that point, our rotation and the moon's revolution on the earth will be about 49 days of our current days, I believe, something like that.
oh wow. Okay.
Yeah.
So we're a little bit over time already. So Lisa, I'm going to let you pick the last question
All
that
right.
we can
So
answer.
let's see. Um, okay, so a couple of them have to be about what you need to observe Venus. So one of them being, is it true you need windows made of diamond to look at Venus? Or, and the other one being like, did we know it was going to be crushed by the pressure? There are some things you know, and then there's some things you really know once they happen to you. So I don't know that it's true that you need windows made of diamond. It would also depend on where you want to look. It would be easier to have a spacecraft descend through the clouds that could survive in that sulfuric acid layer and then look down from above, right, where the pressure isn't as high. So you can make all sorts of interesting missions, like maybe have an atmospheric orbiter as opposed to one above the atmosphere to take a look at it. And then the materials wouldn't need to be as well, you need to be able to solve sulfuric acid. Once again, an interesting engineering problem. Um, in terms of knowing the pressure and the temperatures, um, I'm not sure how much exactly they knew. I think they knew it wasn't going to last a long time. I still think the extent of the pressure and the temperature might have been a surprise. Uh,
Mm,
During these first trips to Venus with robotic spacecraft in the 70s, we still didn't have infrared astronomy the way we do today in terms of being able to make good temperature estimates of things from a distance. So we had to guess more, basically using things like the ideal gas law. Well, hey, if it's this temperature made out of this stuff, you know, PV equals nRT, that sort of thing, like, and trying to estimate. We can get better guesses and better estimates now by our technology. So we know a little bit more of what we're getting into before we get there nowadays, if we can see it. But yeah, so hopefully, if I've convinced you of anything, is that Venus is a hard place. Although it looks like it should have been Earth's sister planet, right? Same size, nearby, atmosphere. That should have been the easy place. And it's like, oh no, no, it's not. And that's why when we tend to think of exploring the solar system more with humans, we tend to think Mars, not Venus.
Thank you so much for your time tonight, Lisa. It was wonderful as always. I
Thank
learned
you.
a lot, which I enjoyed, so thank you for that. Thank you everybody for joining us. If we didn't get to your question, but you really wanted an answer to it, email me the email address and I'll put it in the chat real quick, just so we all have it. If I can, where's my chat window here? Ah, there it is. So I'm going to put it in there. It's adultprograms@rhfleet.org. It's not terribly difficult, but it's always better to have it in front of you if you're looking for it. So just email me and then I can shoot it to Lisa. She'll send me the answer back and I'll email it to you. So if you have that burning question, don't let it go. We want you to have your answer and we'll do our best.
Yes.
And then for the, we have more Sky Tonight coming up and we do expect it to be online for just a little bit longer due to the COVID situation. So for September, we have Observatories of the World. So Lisa will give us a tour of all of them. And I find them highly fascinating. There's a couple I would like to visit. So I'm looking forward to that talk. And then in October, we're going to talk about the life cycles of stars. And if you're interested in any other kind of science talks, we do have our first Monday of the month is our Sharp Minds lecture series. It's pretty much like this. We have a scientist giving a presentation and we have a Q&A afterwards. But we also have our Suds in Science, which is the second Monday of each month, 7 to 8 p.m. It's the same time. We're trying to make it easy for everybody. It's just the date of the month that changes. That is a little bit different. We will be in a regular Zoom, so we will all see each other. And it's going to be more of a conversation with the scientists. So there won't be any PowerPoint. It will, well, sometimes there will be, just because of the subject matter, but most of the time we'll just try to keep it very conversational so that we can glean a little bit more about the personality and the life of a scientist. And you can get all the questions answered, hopefully, in the time that we have. With that, I want to thank you all for joining us tonight. I hope we will see you again next month, either at Sky Tonight or any of the other talks. We're here for you, for your burning science interests and questions, and we really appreciate your support to help us continue to bring science to San Diego while we are still closed. We are still closed. We're not quite sure when we're going to reopen. It all depends on state and city, county measures that need to be taken. So, but stay up to date with us through our website, through our social media channels, and as soon as we are allowed to open again, we will let you all know. So hopefully we can see each other in person soon. But if not anytime soon, I'm really happy to be able to see you all here in the virtual world. Lisa, thank you so much.
Thank you. It was wonderful, and I hope to see you all next month again.
Thank you. Everybody have a great night and be safe.
Good night.
Bye. Let's stop recording.